Thank you everyone for tuning into another episode of Coding Talks with myself, Vishnu. I am a .NET programmer from Thiruvananthapuram, having extensive work experience with cloud technologies like Amazon and Azure. I do have an YouTube channel called Coding Talks with Vishnu, which is of the same name as this podcast, and also a meetup group which is Coding Talks Cloud Computing. If you subscribe to my YouTube channel and if you join that meetup group, which is free, just you need to sign in to the meetup.org and sign in to the Coding Talks Cloud Computing group so that you will get upcoming notifications about my sessions. Also, all the past sessions that I took are available from my YouTube channel as well. So in the coming days, my audio podcast will also be available on the YouTube as well. Feel free to listen from any of your platforms as you like. It is available on Spotify, Amazon Music, Apple Music, and many other platforms, and now it is coming to the YouTube as well. So if you have an YouTube app or if you have a YouTube Music app, you can listen from there as well. So that brings more audience to this podcast. And once again, thank you for listening this podcast. And today I will be going to talk about the Generative AI on AWS services. Last week I took a session on Generative AI and it is available on my YouTube channel. That session is a live streaming session, video session around 2 hours, and it covers extensively about the Generative AI, its history, and also how we can leverage the Generative AI on AWS services. I had a demo on the Amazon SageMaker as well as some introductions into the Bedrock, and also a demo on the Whisperer as well. So if you prefer a live demo or a live video version, feel free to watch that session on my YouTube channel, which is there. The title is Generative AI on AWS. This podcast is similar to the session, but this is an audio version, and those who prefer an audio version can listen this podcast and can understand a bit about the Generative AI, its history, and also how you can get into the Generative AI, especially if you are a developer or if you have some development experience with the with some whatever coding languages that you are familiar. So Amazon made it very easy through their SageMaker service that with some clicks and confirmations you can kickstart with the Generative AI models. Before we coming to there, we can look into some of the history of what is Generative AI and how it evolves. So if you are listening some of the latest news and all, you may be already familiar with the terms GPT, ChatGPT, artificial intelligence, machine learning. So these are some of the associated terms, and this Generative AI is a kind of a branch of artificial intelligence where the system uses foundation models or pre-trained models to generate content. So we can start from the history of how these generative models evolve. So before that, we can look into some of the traditional ways by which how we were solved the business problems. So business involves decisions. Sometimes that decision needs to be taken by an individual. Sometimes nowadays it can be taken by machines as well. Traditionally, we resorted to some form of conditional execution to take a decision. especially from the point of view of automation. If you have two choices or multiple choices, from the system level, you can have an if condition and you can select it. And later, it further evolved into two-dimensional vector models where you can associate a set of words and its patterns. So that means, take for an example the case of word like cat and dog. These are animals and they are come relatively close together. They do have significant differences, but from the machine point of view or machine language point of view, it can be understood like kind of a related terms. And similar way, there are other related things as well, like the for example the car or the bus. So these are vehicles. So these are relatively different from the way by which dog and cat behaves or it works. So by representing these word embeddings or these representations in a two-dimensional space, the system can understand how it relates to each other and how it differs, how the words like dog and cat differs from other words like car and bus. This way, if the system has a list of associated words which we can understand in more meaningful ways called the tokens, and if it can, we can relate if the machine can relate them each other, we can achieve a better decision model than having an if condition. Because if you look into the if condition, it's kind of an hard-coded way by which the system identifies the thing. So this vector representations like the dog, cat and car, bus in a two-dimensional space is much more interesting than the simple conditional based execution. So that's how it evolves from the conditional based execution, then the word embeddings. So this means we have a dictionary of words which can span up to GBs of data, and from that, if the system has a processing capability, it can arrive at a conclusion what decision to take and based on these tokens or words. Then it further evolves. So further evolves into some of the different ways by which it's called the language models. So these language models are different from the earlier from the language model that we are nowadays familiar with. So these are the language models I am going to explain is a kind of a word to vector models, which is a kind of a pre-existed language models where it has a set of tokens, and through the help of that multiple tokens and its associations in a two-dimensional graph, the system can identify how it relates to each other, and it can provide better recommendations. So that means if you watch a movie in some streaming platform, it can arrive at a conclusion like, okay, you may like this another kind of movie based on the genre of movie that you watched. So if you watch a horror movie, it can understand like, okay, you may watch another horror movie of the same kind. So these are kind of a dictionary of words and its association, and then it evolved into a kind of a further evolved into a model called natural language processing. So you might be already familiar with these natural language processing or NLP. Some of the use cases of this natural language processing are text summarization. Text summarization means if you have a large set of data spanning in paragraphs, the system can summarize it. Also question answering sections, where you might be familiar with the concept of chatbot, where based on a set of predefined questions and answers, the chatbot can interact with you and can provide a meaningful conversation. Similarly, sentiment analysis is also possible. With a huge collection of tokens embedded, the system can come to a conclusion like what's the mood of a particular statement, or when we type something into the system, it can identify what mood we are in. So it's called the sentiment analysis, and already there are a lot of sentiment analysis services are available from the cloud, including the cognitive services. Then the speech language understanding. So this is a way by which we interact with the system. One familiar example is Amazon Alexa, where if you want to listen some music, you can instruct the Alexa to play some music and Alexa will do that for you. So how it understands these things is having a collection of tokens and words. It can come to a conclusion that you intended this thing. So the intention of the user can be identified from a set of words or a collection of words or even a sentence. So that's called the natural language processing, and this was quite existed back from I believe around 5 years back, because around 5 years back I have taken a session on the chatbot, and the chatbot features the same thing. So the way by which the chatbot works is like when we provide some text or something in the form of a conversation, the chatbot can understand the intent of what we meant through that sentence, and then it can trigger an action. So that means if you start telling Alexa stream a music, then it can understand that you want to stream the music and it will trigger that stream music action. So instead of conditional execution as we discussed initially, this model using the natural language processing is bit more advanced because it involves it's far not bit more, it's far advanced because it can understand your intent in a way familiar like a human conversation. I have seen a lot of chatbots similar way, like for example, if you want to book a meeting in Teams, you can instruct the chatbot that book a meeting at this time and it will do on behalf of you. Similarly, if you want to book something in the calendar, you can instruct the Alexa to do that and it will do. So natural language processing is more convenient for a user because we often use the language way to interact with others, and that feels more natural for us. And if you interact with the system in such a way, it is much easier than having a set of clicks and interacting with the system in a kind of a robotic fashion. That's how natural language and the systems associated with natural languages like the Amazon Alexa became very popular. But this has a drawback. Like the natural language processing system can understand some of your intent and what you want to achieve through the system, but still it's not capable of predicting or generating a new content based on what the context of what you intend. So for example, if you are mentioning to the system for using a natural language system like what will come before the word lazy, the NLP system will feel difficult in identifying what you intend because it cannot understand the context easily. It can understand an intention of you, but it cannot understand the context, and it cannot understand what you intend, or it cannot provide a recommendation based on that. It can provide some related recommendation based on the dictionary sets that it have, but it cannot understand the context just like we humans do have. Our neural networks has the capability to understand the context based on the memory, and it can provide a conclusion when we hear some words. So when we know the word lazy, we can understand that one of the most familiar English language sentence like the fox jumps over the lazy person, and similar like that. So the point is like this way we humans can understand based on the context. Or if someone is saying like I want to watch a movie, then based on our understanding and our understanding about the context of the situation, we can come to conclusion that oh you are going to watch this movie which is happening in that theater, because our memory has the understanding of those things. Similar way, there is a technology that evolved which is called the recurrent neural networks, which is a predecessor of this GPT. We can simply call it as RNN. The idea is this RNN networks can predict. RNN means recurrent neural networks. You can search about that in the Google. What this means that using this RNN, the system can predict the next word with the context in memory. So that means it have the context of a large set of data in memory, and based on that memory and based on the thing input from the user, it can arrive a conclusion about what the user intends, and it can provide some form of next word prediction as well. So if you type something like what is the next word after this, or the quick fox jumps over the lazy dash, it can provide an answer like something like dog or rabbit or person or something. But still the recurrent neural networks is not capable to provide an accurate answer, because it is working based on the current context in the memory and based on a set of data, but it cannot come to the exact conclusion to how to predict the best next word. So there comes the importance of a paper which is released in 2017. It's a paper submitted by a few individuals, and in it's the introduction of these models, we can say. Like in that they have mentioned a kind of an abstract where if you add attention to these set of data, the system can identify to a better prediction model. So that concept is called the transformers, and the current GPT model is based on this transformer technology. The difference is that just like we humans can give an attention to a set of words and its context, the system also can, through its massive parallel processing, it can from a set of data, it can focus on a set of data and can provide attention to a particular word, and that way it can provide the best context or best words that are suitable for that context. So that means if you type the transformer model something like I want to go to, then based on what you type and based on how it interacted with you and from the set of other data that it have, it can arrive a conclusion, it can arrive a attention to understand the relationship between the words, and then along with that it uses a kind of a processing called parallel processing. Parallel processing means simultaneous processing with multiple cores, and then it will arrive at a conclusion like this word is to be come next. So when you type something like I want to go to, based on the context and the time and other data that it have, and based on how it interacted with you, and based on that data it will suggest you like you want to go to market or some other place. So that's how the transformer architecture works. Just like when we humans learn things more, we can provide or understand better context. So similar way, this transformer model, based on how much input we can provide, it can arrive at a conclusion or understanding the relationship between words. So how it achieves this is through the concept called the attention and also the efficient use of the parallel computing. This means that these models are kind of a huge GBs of data, and it needs massive processing capabilities as well. That's how the current evolution of cloud helped to bring these transformer models into cloud, which the services like Amazon, Bedrock and SageMaker do, which can be utilized by us with minimal cost, and we need to pay only for what we are actually using. We don't need to train a model from scratch. That's the main advantage, because these language models are already there, and we just need to add some domain specific data on top of these models, and we can achieve our domain specific requirements, or we can automate a lot of things. That's how it is getting popular. Many of you are already aware about the ChatGPT. So the ChatGPT is just a chat extension of this GPT model. You are interacting with the GPT model, which is a kind of a chat optimized model. So what this means is that model can converse with you in an interaction model based on the transformation capability that it has. So that's called GPT model, and ChatGPT is a way of interaction. similar way you interact with the GPT models through chat, the systems can also interact with the underlying GPT or foundation model and can come to a conclusion, just like the way by which the earlier systems can come to a conclusion based on decision like if loop, and then later the NLP model. Nowadays it is achievable through the transformer model as well. So this means that if you ask a GPT model or a transformer based network, the quick brown fox jumps over the lazy, and if you wait for a moment, then it will suggest the exact word like a dog. Not only it can suggest, it can also provide more information about that word. So that means that if you ask that same word, it not only just it provides the missing word dog, it can also provide some additional information like it's an English language, a sentence that contains all the letters of the alphabet. It can also provide information like this phrase is commonly used for touch typing practice. So that much intelligent it is. Intelligent in the sense like it has the capability of attention and parallel processing. So this is how it is working, and this kind of trained models which is capable of doing this kind of transformer based tasks are called the LLM models, or large language model. These large language models are huge in size. So if you look into the earlier version of the GPT model, which is called the BERT, which is around 345 million, and later the GPT-2 has 1.5 billion parameters are used there. So this is the parameter count. So BERT has around 345 million parameter count. So what a parameter is, this parameter are the way by which this language model understand the context of what the user intends. So the more parameters it have, the better it can respond to user queries. Not just user queries, better it can take decision. BERT has around 345 million parameter count, while the GPT-2 model has around 1.5 billion, and the upcoming GPT-3 model, which is already available for beta, which is having 175 billion. So you can see the parameter count is getting higher and higher. So that means it will go like a kind of an exponential way. And then the Bloom, which is also another model which is used within the Amazon, which is also having 176 billion. So this means that Amazon already have some experience working with the different systems, like the shopping is one of the popular system, and there are millions of other customers are also powered by the services of AWS. So Amazon has a huge set of underlying LLM models which they can use for this generative AI purpose, and they have integrated quite a lot of such similar models inside their services like the Amazon SageMaker and also the upcoming service which is called the Bedrock. We will cover about a bit of those services as we go along. What this means is that the underlying language models which Amazon has expertise can be used for our domain specific purpose as well, and our data that we add on top of those models will remain private. So none of the data which is used in these services will go public. That is another advantage of using Amazon Web Services. Like if you use something in ChatGPT, that will definitely go to public. It's used for public training. But what you use inside this language models inside the AWS services like the SageMaker and the Bedrock. Bedrock is an upcoming service. That data which you add on top of that remains private. So this means with the underlying capability of existing specialized foundation models, with relatively very little time, you can make a better model which is capable of doing your domain specific task. Instead of developing a machine language model from scratch, you can achieve it the expertise of these foundation models, and then you can add some domain specific on top of it. If you want to develop a language model from scratch, you can have it using the AWS SageMaker, which also provides you the facility to spin up a machine language model and you can train it. But training is not an easy thing. You need to train it on different context of how an user interact with it, and then the more you train, it will achieve it providing better decision context. That means you need to invest a lot in training these models, which is quite an expensive process. Now we are outsourcing those things to Amazon Web Services, and Amazon and the associated the vendors have these language models they have trained, and we can use them without going through training a machine language model by our own. And also another thing is, like, if you want to train a model, you need expertise of data scientist, this domain specialist and all, which is not required as in the case of this foundation model. So that means you can relatively easily get into the machine language spectrum with this kind of things, like this kind of services like the Bedrock and the SageMaker. While we have discussed about these different language model or LLM models, one thing I want to mention here is there is a sub-concept of, there are sub-model under the LLM models called the foundation models as well. So how this foundation model is interesting is that while the LLM models are very large and it can do a set of generic things, these foundation models are kind of relatively smaller models which can do specialist tasks. While we understood, like, okay, these are very smaller models, don't assume that these are less capable than the LLM models. What we need to understand is that these foundation models are specialized models, specialized in a certain task. That means if you go to the SageMaker, you can find quite a list of the foundation model or the jumpstart models which are optimized for certain tasks. Some are optimized for doing the customer interaction, while some are useful for some other purpose. So based on what you want to achieve, you can have it that specific foundation models and use it. If you want to generate something like an image or a generative image from a foundation model, you can use a diffuser generative model for that purpose. Similar way, if you want to provide some text input, like if you type something and if you want to Rust to be generated by the GPT model, you can have a foundation model for that purpose. If you want to summarize a set of paragraphs, you can have a foundation model optimized for that thing. That way you can use separate foundation model. And another important interesting thing is you can automate all of these things in the SageMaker, and you can use specific foundation model for specific purpose. Different APIs can be created and your systems can interact with the SageMaker APIs once you create a domain. In the demo which I had last week, I display how you can create a domain and an API model from the SageMaker interface. It's relatively easy. You can very easily understand that with minimal programming background knowledge, you can get into the SageMaker. SageMaker is a kind of a drag and drop interface where anyone with relatively less code experience or development experience can also get into there. You don't need to write any code or anything specifically there. Just you need to have some basic understanding and you can get into that. And once you understand that, then some developer can develop an application and interact with this SageMaker API. That way they can interact with the underlying foundation model. We can come into those areas a bit later. Now, given that you have understood a bit about what is LLM, these are large language models, and then the foundation model, which are specific models. Next, we can look into one of the offerings by Amazon Web Service, which is called the Code Whisperer. So this is a generative AI pair coding, which can help you to do the coding, and it is comparatively free for use as well. What you need to do is you need to install a particular extension for this, using this, enabling this Code Whisperer, and then you can use that inside your Visual Studio Code and other editors. I have tried this and I find it very interesting. The thing is, like, the more you interact with the underlying GPT model, this is free. You can just connect your existing code to the Amazon Code Whisperer. It is simple. Just install the extension in VS Code called the AWS Toolkit, and once you installed that, you need to connect with the Amazon Code Whisperer account. So that means you need to create a AWS account. It's different from the account you used for AWS services. This is a developer account, and then you can connect it to the AWS, and then that way, once you connect it to there, automatically when you type something in your Visual Studio Code, Whisperer will provide you the suggestions, and you can also provide inline comments by providing some comments on top of a function. For example, if you want to create some model or some function for counting two numbers or whatever way, or creating a Fibonacci series, automatically they are based on the context. Context means what language you are in. The underlying Code Whisperer APIs will interact with your Visual Studio Code and automatically fill the details for you. So you need to experience that. A demo of this has been taken in my session and in other videos as well, which are available in the code. So feel free to look into there and you can understand how the Whisperer will work. One of the advantage of this is that it provides a kind of a pair coding way by which your coding can be improved. It says like around, I don't exactly remember the percentage. So if you go through the Whisperer blog, you can understand how many organizations are actually using the Whisperer for improving their productivity. It behaves exactly like a pair programmer. Pair programmer is a concept where you will ideally be doing the code and someone sit with you and help you to do the coding. So he or she will watch the code and then can provide you some suggestions. So similar way, the AI behind the AI Code Whisperer model will automatically watch what you are typing, and then it will provide the context and information, and it can help you in code even. So this means that if you type a function like a function imported to S3 bucket, it will automatically show the related code there. And it works better with the Amazon Web Services. There are around 200 plus services in AWS, and this Code Whisperer can provide better recommendation for those AWS specific services. But that is not just limited to the Whisperer, is not just limited to the AWS services. It can provide a lot of other context as well. So it supports up to 15 languages. Some of them I tried are C# I have tried, and JavaScript I have tried and find it quite interesting. And some of the documentations in the AWS Whisperer documentation shows examples of Python working well with that as well. So you can try other codes to see how it looks like. So these two I have tried, like C# and JavaScript, and I found very interesting, and it is really helpful, because if you if you are not comfortable uploading something to the S3 bucket, or it's not just S3 bucket, there are many other things as well. But if you type, just an example in this case, if you type something like that, then the Whisperer will automatically provide the suggestion, and after you type for some time, it will learn the way by which how you code, and it can provide suggestions based on how you write the code. It can also do a security scan as well. Sometimes we developers focus too much on the functionality, so that we miss the security aspects as well. Code Whisperer is quite useful in such cases. It scans whatever we are doing, and then it can provide security recommendation as well. That means if you type some keys or something, AWS specific keys into the Whisperer connected code editor, then it can identify and suggest you. The difference is that the security scan will happen for the entire context of files which you connected to the Visual Studio Code, while the in-context suggestions are provided based on the context of that file and the functions which you type. So it's really helpful, and you can try it. And there are a couple of other things also I find it interesting. When I try to do a particular method, automatically the underlying Whisperer API identified this and provided me suggestion. Not only it provided a single suggestion, with the combination of arrow keys you can switch between multiple suggestions, and once you are confident with a particular word, suggestion, you can accept it by hitting on the tab key. That's how it's work. So that means a combination of tab and arrow key, which once you're comfortable working with the Whisperer, you can select the best selection of recommendation and use it. Sometimes Code Whisperer is unable to provide suggestions. In that case, as you go further and further into the code by writing 2 or 3 lines, then it will start to provide you suggestion. The plugins of this Code Whisperer are available in the Visual Studio Code for sure. I have tried that. I expect it to be coming soon on Visual Studio as well, so that I can have a play. Visual Studio Professional is one of the most used editor especially for C# and .NET programmers. I believe AWS will release a version of the plugin for those editors. Well, currently it is available for VS Code and a set of other editors, including JetBrains. You can have a check on their documentation to see what all editors are supported. Maybe at the time you listening this podcast, more editors will be supported. This is one of the application of generative AI. Like it can provide a recommendation. The example which we just discussed about Code Whisperer, it can help a developer in doing a kind of a paired programming and can provide suggestion. Similar way, other areas of or applications for generative AI are there, like the text generation. Text generation comes into many categories. It's not just one category, many categories. Text generation involves various use cases. Say for example, if you have a set of 3 to 5 or more paragraphs and you want to summarize it to send an email to some customer or some person, generative AI can do on behalf for you. And you can also train the generative AI if you use the service inside AWS. So that means your domain specific data will remain private inside a VPC, and the underlying generative AI can generate a summarization of text based from a set of your organization documents. And another use case is like if you want to generate some advertisement content based on a set of successful advertisements which happened in past few years, you can train the generative AI with some advertisement specific foundation models. You can train the generative AI with a set of past few years data, advertisement data, and then can inform the generative AI to generate a new advertisement. So this new advertisement suggestions or text will be entirely generated from based on the past set of information which you trained for the model, but this is entirely a new content. It's not a copy content from the past one. The generative AI will generate the text just like a person can generate something from the inspiration, something like an inspiration from a set of past few documents. So this means that generative AI can use in other areas as well, like the music generation, where if you provide generative AI with a set of music or medias or which interesting medias that you like, then it can provide a similar content for you, entirely new content. And this new content is specifically copyrighted for you, and you can use it, and none else can use that. So that this way, generative AI has a lot of use, and also for game design. Game design, of those who playing games, you can see attractive areas coming up, or the context coming up in the game landscapes, and generating those landscapes can be quite easy with the help of this generative AI. You can provide information to generative AI that you need some kind of this kind of landscape, and based on the information that it have, a generative AI will do that for, or GPT models will do that for you. Similarly, other areas, industrial design, then interaction with the customers, and if you want to generate some content based on domain specific information, that can be done. We already discussed that. Then image generation is another interesting thing. To create an image, it is not easy. Either we need to generate grab a set of images, and then we need to understand how that image is, and we need to either recreate that new image either with the help of an artist or some editing tools. But with this generative AI using the diffuser models, you can let the underlying GPT model that you need an image of a whatever way you expect, and then it will automatically generate the image. So how this is achieving in the generative AI space is using a concept called the diffusion. So stable diffusion is one of the technique which is quite popular for generating this kind of images from text. You can search in Google about the different generative AI images or DALI images, or something that AWS services have generated. You can find that those images looks real, but it's actually not a real image. It's a fake image which is generated by the generative AI. One of the technique that is used for generating this kind of image is called the stable diffusion. Stable diffusion works in a way by which we train the diffusion models using a set of images. We provide the diffusion model those images, and what this diffusion model will learn, how it learns is like it will add a little bit of noise over that image, and then it will try to create the image back. It will generate the image back from those noise. Then it will add a little more noise to the existing image, and so on until it can until the GPT models can entirely generate an image purely from the noise. So this noise is called the foundation model. So such way a lot of foundation model exist there, and when we train the diffuser model, it will learn this way and store that in the underlying context. And then what it will do is, when you provide some text based inputs like a dog standing on a seashore, based on the underlying foundation model that it has. In this case, dog and the seashore, and then it will automatically try to generate that image. So that's how it's working. It's an interesting concept. You need to look into the Google to understand how how interesting those images are, which are generated by the generative AI models. And also you can check into the concept called the stable diffusion, which is one of the way by which the generative models add noise and learns how to work backwards to the original image. So initially it adds a little bit of noise and learns how to work backwards to the original image, and then it will do adding more and more noise until it learns to work from a random noise to generate an image. So this is called the stable diffusion. And a lot of such models, stable diffusion models, are available from the AWS SageMaker, which you can try. The benefit of using AWS SageMaker is that you can create an account in SageMaker or an AWS console account, and then you can start using the SageMaker. In the SageMaker screen, you can create a machine language model from jump starts. So a lot of jump starts are provided there. What you need to do is you select an appropriate jump start. If you want to try out a diffuser model, you can select that diffuser model and then you can deploy that model. It will take some time to get it deployed. Before you need to deploy, you need to create a domain as well. Domain is a kind of a workspace that is for you within the AWS SageMaker. You can use that workspace for doing your activities. What it does under hood is like it will associate a set of storage and the file system spaces for spinning up these LLM models or foundation models. So once you have a domain, the domain is the first thing you need to create, and it will create an underlying context, and also you need to provide a execution role as well, because everything in Amazon Web Services is requires a permission to connect to that service, whether if you are connecting from one service to another or if you are interacting directly with a service, you need permission to do that. As an administrator, you have the full permission, but this SageMaker to connect with the underlying context like the storage spaces and the buckets. S3 bucket is also used for SageMaker. For that purpose, you need to initially create a domain. Once you create the domain, all the required permissions and all the underlying services are set properly, and then after that you can find a jumpstart model. The easiest way to start is to find a diffuser model and then deploy that diffuser model. It will take some time. Please be patient, and within 5 to 10 minutes it will get deployed. Once it gets deployed, some of the jumpstart models do have the playground facility available. The benefit is that you can AWS itself provide a prompt so that you can type a text and it will generate the image for you. Or the other way, some models don't have the playground. In that case, you need to deploy it and then you need to run as a notebook. So notebooks is also interesting. So in this jumpstart, they will provide you the notebook and the code in Python. You can execute the code line by line and you can see how it works. Additionally, an underlying API is also available. If your applications want to connect with this underlying SageMaker model, that can be used. So how it gets charged is based on the amount of time you are actually using the foundation models, and it varies with relation to the foundation model which you are using. Lot of foundation models are there. So we have talked about the generative AI in general and some of its use cases. Two of the use cases we already discussed are mainly discussed are the the recommendations which we found in the Whisperer and also text generation scenarios. Not only that, there are many use cases, and another use case is called the prompt engineering, which is another concept. Prompt engineering means that you can prompt the generative model to do something for you. It will generate the context. So this means that if you want to write a blog and if you are not sure how to write a blog, there are GPT models or foundation model which are optimized for that task. What you need to provide is you need to provide a title, you need to provide a topic, and you need to provide how many paragraphs you want, and you can click on OK, or you can input that thing to the prompt engineering models and it will automatically generate the context or content for you exactly as you say. But how better it perform depends on the foundation models we use. So there comes the importance of training these models. So when you take a powerful model or capable model, it can work that effectively. So that's the reason why this popular cloud services like AWS, which has quite an extensive training data available with them, and AWS also partnership with lot of other services as well. So that means you have a set of various capable foundation models specifically tailored for certain set of tasks and available for you, which can be used for specific purpose. This needs to be keep in mind. You may be wondering why are we using this foundation model, because it's trained by someone, but training is not an easier thing. To have a new machine model built from scratch, it takes a lot of effort and time, especially it requires specialized data engineers, data specialists, and also lot of training data to accurately come into the picture. So that means just like the open source community benefits from each other, having the associated training and learning from AWS can be utilized, combining the information from our domain specific area. That way we can achieve a better foundation model which can be used for further automation for our task. Imagine the case of just summarizing a set of organization document. If you instruct a person to do the summarization, he or she should go through the different documents and then take quite a bit of time to summarize that. But this is another area I want to mention here. When it is done by a human, it has its benefit, especially if they can do that in a effective way. If it's done by an effective person, that will be much better. But the problem is the time. It will take some time. So machines have the capacity to go through a long set of documents and paragraphs within a relatively short time, and it can provide, based on the underlying model capability, it can provide the summarization quite effectively, equal or more better than a person can do. But still, because it is generated by a machine and it's based from the GPT model, you need to validate the information that is available from the model, and then you need to use. This is one of the current recommendation which many GPT enthusiasts also say. We can't entirely trust on this data. It's still in evolution stage, but there are still it's reached a stage from we already understood from the chat GPT and all. We understood like the underlying model GPT-2 itself is quite capable of answering a lot of things. So GPT-2 model is also available on this AWS SageMaker. You can look into that and you can use it. Then a new service, upcoming service is coming from AWS called the AWS Bedrock. This is a managed service and it's quite easy to use service. It's still in preview. You need to look into the web page and then you need to add in the waiting list so that you will get a preview of the Bedrock when it is generally available. When it is available for a beta testing, you need to provide some information and hope soon it will be available to general public, and we can use that as a kind of a managed service. What Amazon mentions is that these Bedrock has few different models. So let's just a moment. I just going through the Bedrock models. So these are foundation model API. So some of the quite interesting use cases of this Bedrock are they are mentioning that they have foundation models which can be useful for text generation. This means we can create new pieces of original content such as short stories, essays, social media post, and web page copy from the user input or the context. Also, chatbot optimized models are there which can use conversational, which can be quite useful for generating conversational interface such as chatbots and virtual assistants. Also, search is there, want to find something, and the image generation diffuser models are also available. Then personalization models are there. As of now, at the time of this recording, the major 4 foundation models are available, which is called the Jurassic 2 from A121 Labs, then Cloud from Anthropic. Jurassic 2 can be used for text generation in Spanish, French, German, Portuguese, Italian, and Dutch. It's a multilingual LLM. Similarly, Cloud from Anthropic, which can be used for conversation, question answering, and workflow automation based on research and training honest and responsible AI systems. Then Stable Diffusion from Stability AI, which can be used for generation of unique, realistic, high-quality images, art, logos, and design. And also Amazon's itself foundation model called the Amazon Titan, which can be used for text summarization, question answer, information extraction, and also embeddings and searchings. So these are some of the 4 foundation model which we can expect from the AWS Bedrock. While at the same time, some of these models are already available in the SageMaker, which is another product. SageMaker is a product, is a machine language service which can be used for generating a new machine language model, or it also has some of the existing quick start or jump start solutions where you can use specific foundation models under the hood to automate your task. You can have a try it from SageMaker Studio itself, and also you can have an API to automate it from your application as well. So these are some of the things that I plan to cover in this today's session. If you want to get a better understanding about how this looks in action or demo, you can check out my last week's demo, which is available from my YouTube. There are upcoming sessions coming on the S3 and also DynamoDB, which will be coming in the coming days. So thank you very much for listening to this podcast. Have a great day.